Welcome to the Deep Dive. We're the show that digs into the sources to get you truly informed. Today, we're tackling a word you hear, well, everywhere. Algorithm.
It really is everywhere.
Right. Search engines, social media, GPS navigation, streaming recommendations. Algorithms are kind of the hidden wiring of modern life, shaping what you see and do.
Constantly, often without us even noticing.
Exactly. But have you ever actually paused and thought, where does that word even come from? It doesn't sound particularly modern or technical, does it?
No, it really doesn't. And the origin is frankly amazing.
So what is it?
Well, the word algorithm itself is actually a Latinized version, algorithmi, of a name. The name of an incredible figure from history, Muḥammad ibn Mūsā al-Khwarizmi.
Wow. Okay. So the word comes directly from a person's name.
Directly. And our deep dive today is all about him, because he was so much more than, just a name in a math textbook. Sometimes he gets called the father of algebra, which is true, but it barely scratches the surface.
Yeah, I think that happens a lot with historical figures, right? We reduce them to one single thing, like he's the algebra guy.
Exactly. Almost like a technical footnote. But our mission today is to unpack al-Khwarizmi as, well, a truly visionary thinker, someone whose work wove together mathematics, philosophy, metaphysics, even in teaching, pedagogy, into this unified way of understanding the world.
Okay, so we're talking about a synthesis here.
A huge synthesis. You're going to see how Greek rationalism, Indian numerical ideas, Persian metaphysical traditions, and Islamic ethical thinking all came together in his work. He created this new paradigm for learning and even for being.
So understanding him means understanding the Islamic Golden Age much more deeply, not just the scientific breakthroughs we hear about.
Precisely. It wasn't just about discovering things. It was about how knowledge was pursued. It was linked to morality, to spirituality, to understanding reality itself. His work is like a window into that whole mindset.
That's fascinating. And we'll get into his specific context too, right? The famous Beit al-Hikmah, the House of Wisdom in Baghdad, under the Abbasids.
Absolutely.
Yeah.
We'll explore those elite scholarly circles. So get ready to maybe rethink what knowledge even means and how it was pursued, really as a sacred duty, centuries ago. It might change how you think about learning itself.
Okay, let's dive in.
Let's do it.
So the Islamic Golden Age, many people know it for, incredible strides in science, astronomy, medicine, math.
Highlights.
But what often gets missed and what our sources really bring out is the underlying educational philosophy, the whole pedagogical architecture. It wasn't just about finding useful facts. Knowledge itself was seen as, well, a sacred discipline.
Which begs the question, what kind of place fosters that view?
Mm.
Because it's quite different from how we often think about education today.
Right.
Al-Khwarizmi's vision didn't come out of nowhere. It was deeply rooted in this intellectual and spiritual environment. He was right at the heart of it, working in the Beit al-Hikmah in Baghdad.
The House of Wisdom.
Exactly. Which sources describe as almost like a proto-university, an academy of sciences, heavily supported by the Caliph Muḥammad. And this place was a magnet. It pulled in scholars, translators, thinkers from all over the Islamic world and beyond.
So it wasn't just a big library then. Sometimes it gets pictured that way.
Oh, much more than that. It wasn't just collecting books. The sources call it a crucible, and I think that's the right word. Imagine Greek philosophy arriving, Indian math texts, Persian astronomy research,
All in one place.
all converging. And scholars weren't just reading them passively. They were translating, yes, but also debating, critiquing, synthesizing, trying to make these different traditions talk to each other.
Actively building something new from them.
Exactly. It was this incredibly dynamic intellectual ecosystem. It fostered this kind of intellectual humility, too, I think. A recognition that wisdom wasn't confined to one culture. And that environment was absolutely key for someone like al-Khwarizmi.
Okay, that context makes sense. And it's within that context that scholars talk about this Oriental pedagogy.
Right. T.M. Aminov and colleagues point to al-Khwarizmi as a key architect of this distinct approach to education that really crystallized in the 9th century. And the core idea wasn't just about training the intellect. It aimed to form the soul of the learner.
The soul. That's a powerful word in this context.
It is. This model saw spiritual growth, ethical behavior, and rational thinking, not as separate tracks, but as interconnected, mutually reinforcing elements, all aimed at creating the ideal person.
It sounds holistic.
Very holistic. And it's fascinating because, in a way, it anticipated some Enlightenment ideals by centuries, but not by rejecting faith. Instead, it saw learning as a sacred duty. It elevated the pursuit of knowledge itself.
So unlike later European thought, where reason and faith sometimes clashed.
Here, intellectual rigor was seen as a path towards deeper faith and better moral character. You couldn't really separate them.
Okay, so scientific knowledge, self-improvement, spiritual practice, they all fed into creating a fully developed personality. That feels very different from modern education, which often silos these things.
Absolutely. For Al-Khwarizmi and his contemporaries, intellectual rigor had to be paired with moral cultivation. You couldn't be truly learned if you weren't, well, virtuous, and vice versa.
The knowledge itself wasn't neutral.
Never neutral. It wasn't value-free. It was seen as a powerful means to perfect the human soul by harmonizing reason, faith, and how you acted in the world.
And this changed how learning itself was approached. It wasn't just about memorizing facts.
Definitely not just memorization. The model rejected that passive approach. It emphasized active engagement with the world, with the cosmos, with the texts. Learning wasn't just cognitive growth, it was framed as a kind of spiritual journey, a pilgrimage towards understanding the divine order behind everything.
Wow, so every discovery, every solved equation
Was potentially a step closer to perceiving that divine structure. It makes the whole endeavor feel much more profound.
And you mentioned it was seen as an act of worship. Ibadah.
Exactly. This tied directly into Quranic injunctions to reflect on creation, to seek knowledge. So for Al-Khwarizmi, think about algebra. It wasn't just manipulating symbols. It was like learning a divine language, a tool to decode the deep structures of reality.
Finding God in the equations almost.
In a very real sense, yes. Finding the underlying patterns, the balance, the harmony that pointed towards a creator.
And this whole approach, this pedagogy, it had a lasting impact.
Immense. Al-Khwarizmi helped shape an educational system designed to preserve knowledge, but also renew it across generations. It stressed continuity, humility, reverence for what came before.
Which is different from some modern ideas about constant disruption, always needing the new.
Very different. Here, innovation happened, absolutely, but it was built on respecting and understanding the past. The student was like a curator and a builder, not just a rebel. Preserving the wisdom was as important as adding to it.
And this found practical form in the madrasa system.
Yes. The madrasas grew out of institutions like the House of Wisdom. They developed structured curricula, fostered specific disciplines, and crucially, they maintained that unity between religious and rational sciences. They didn't see them as separate.
And these spread.
Widely. Our sources say they led to scientific centers throughout Asia and Europe. They directly fed into what eventually became the European university tradition. So his educational vision had this incredible ripple effect, shaping how knowledge was organized and passed down globally.
It shows his impact goes way beyond just the math. It's about a whole philosophy of learning.
It really is. For him, math wasn't an escape from faith. It was a way to deepen your encounter with the divine order of the universe. A truly holistic endeavor.
Okay, that's a powerful foundation. So with that philosophical and pedagogical grounding, let's turn to the scientific breakthroughs he's most famous for. How did that deep thinking manifest in his actual work, his role as a scientific architect?
Right. So let's focus on Al-Khwarizmi, the scientist. As Sonja Brinches points out, he spent the core of his scholarly career in Baghdad, working directly under Caliph al-Mu'min, deeply involved with the House of Wisdom.
And his name, Al-Khwarizmi, it suggests origins in Central Asia, Khwarizm.
It does, likely modern-day Uzbekistan, though some sources hint at connections closer to Baghdad too. But either way, he really embodies that cosmopolitan spirit of the Abbasid era. It was a true melting pot.
And his work reflected that breadth. It wasn't just math.
Not at all. While algebra is the headliner, Brinches emphasizes his range. He created influential astronomical tables, the Zijal-Sindhind. He wrote a major work on geography, the Kitab Rudat Alar, the Book of the Image of the Earth.
Mapping the known world.
Updating and correcting previous maps, yeah. He even wrote a treatise on the Jewish calendar, which shows the practical needs of a diverse empire. But yes, the two works that echoed loudest through history were his books on algebra and arithmetic.
Okay, let's start with algebra. His most famous text, Al-Kitab al-Mukhtar fi Isab al-Jabra wal-Muqabala, the compendious book on calculation by completion and balancing.
That's the one. And it's widely seen as the first systematic book on algebra in the Islamic world.
Yeah.
But here's the really radical part, the game changer.
What was it?
He treated algebra as its own thing, an independent discipline. Before him, particularly for the Greeks like Euclid, algebraic problems were often solved using geometry. Shapes and lines represented quantities,
Ah, okay. So algebra was kind of subordinate to geometry.
You could say that. Al-Khwarizmi essentially said, no, algebra has its own concepts, its own language, its own methods. He gave it its own footing. That was a fundamental shift in mathematical thinking.
And was this just theoretical, or did it have immediate practical
Oh,
uses?
hugely practical. Brendo stresses this. The text, which later got translated into Latin and became foundational in Europe, tackled real-world problems. Things like quadratic equations for calculating areas, measuring volumes.
Okay, engineering and architecture.
Exactly. But also complex commercial problems involving trade and finance. And crucially, the intricate rules of Muslim inheritance law. Dividing estates according to religious prescriptions could get incredibly complicated.
I can imagine. Different shares for sons, daughters, wives, parents.
Precisely. His algebra provided a clear, systematic way to solve these problems. It made complex calculations repeatable and reliable.
So the impact was massive. It wasn't just a book on algebra, it was the book that established it as a method for reasoning about unknowns.
That's a great way to put it. It became foundational for both Islamic and then European mathematics. Algebra stopped being just about finding specific numbers. It became a logic of abstraction, a way to think about relationships between quantities even when some parts are unknown.
Like moving from solving one specific puzzle to creating a general strategy for solving types of puzzles.
Exactly. It's a higher level of thinking, almost like creating blueprints for mathematical reasoning.
Okay, so that's algebra. What about his arithmetic treatise? Al-Kitab al-Jamo wal-Tafriq Biasab al-Hind, the book of addition and subtraction using the Hindu calculation.
This one is equally revolutionary, maybe even more impactful on daily life, though it only survives in Latin translation. This is the book that introduced the decimal positional system and the Indo-Arabic numerals 0, 1, 2, 3, up to 9 to the Arabic-speaking world.
Our modern number system.
Basically, yes.
Mm.
Before this, calculations in the region often used cumbersome systems, maybe letters for numbers or counting boards. Imagine trying to multiply large numbers with Roman numerals.
Yeah, that sounds like a nightmare. So he brought the system from India.
He synthesized and popularized the system originating from India. And the key element, the real breakthrough, was the concept of zero, cipher.
Zero, which we take completely for granted.
Absolutely. He used it as a placeholder.
Yeah.
So you could easily distinguish between, say, 205 and 25. Before this, you needed other symbols or context. Zero made the positional system work efficiently.
Even though he didn't quite treat it as a number in its own right yet.
Not quite in the modern sense, more as a placeholder marking an empty position. But its practical effect was immense. It streamlined calculation enormously, allowing for much greater complexity in science, in commerce, in everything. It was the vital bridge carrying Indian numerals westwards.
Incredible. And beyond pure math, he applied the synthesizing approach to astronomy and geography too.
Yes, his Z al-Sindhin, the astronomical tables, are a perfect example.
Yeah.
He drew on Indian sources, Persian, Sasanian traditions, and Greek knowledge, especially Ptolemy's Almagest.
So he wasn't just sticking to one school of thought.
Not at all. Bridges calls it a cross-cultural patchwork of precision. He'd take solar data from Ptolemy, calculations for planetary motion from Indian texts, models for certain equations from Persian sources. He selected, adapted, compared, refined. He was building a better, more comprehensive model from the best available pieces.
A true synthesizer. And did these tables catch on?
Hugely influential. They were copied, revised, and used by astronomers across the Islamic world from Baghdad to Spain, and they directly impacted European astronomy too.
Through translations?
Yes, scholars like Adelard of Bath, Abraham ibn Ezra, they knew his work. The famous Toledan tables, compiled in Muslim Spain around 1060, incorporated many of his values. His work became a cornerstone for centuries of astronomical calculation in Europe as well.
And his geography? The Kitab al-Art.
Same approach. He started with Ptolemy's geography, which was the gold standard. But he didn't just accept it wholesale. He and other scholars in Baghdad collected new data, new observations from travelers and astronomers, and used it to correct and update Ptolemy's coordinates for many places.
So science in action testing and refining existing knowledge.
Exactly. It shows that dynamic, iterative nature of science. Knowledge wasn't seen as static or finished. It was always a work in progress, needing correction based on new evidence. A very modern scientific attitude, really.
Looking back at all this, what really strikes me is the underlying philosophy. It wasn't about claiming my way is the only way.
Not at all. His work breathes this spirit of intellectual hospitality. He openly used Hindu, Persian, Greek sources. There was no attempt to hide origins or claim sole invention in the modern sense.
His genius was more in the synthesis, in translation across cultures and disciplines.
Precisely. He modeled this kind of epistemic humility, a respect for knowledge wherever it came from. He showed that real breakthroughs often come not from isolation, but from bringing diverse threads together. He was a master weaver of knowledge.
Okay, so he was a pedagogical visionary, a scientific architect, and synthesizer. But you mentioned philosophy and metaphysics. How does that layer fit in? Let's explore Al-Khwarizmi as a philosophical engineer.
Right, this is where it gets really deep, I think. Marie Benediktová-Vetrovkova's work really sheds light on this. She argues that Al-Khwarizmi's math work wasn't just about procedures, it represented a fundamental shift in how people reasoned, from the concrete, visual thinking of geometry.
Shapes and lines.
Exactly. To a more abstract, symbolic, and step-by-step algorithmic way of thinking. And she calls this a philosophical reorientation. It wasn't just changing symbols, it was changing the underlying way mathematical thought worked.
So moving beyond just how to calculate to thinking about what numbers are, their nature.
Precisely. This new abstract approach required, implicitly at least, a new ontology for mathematical objects, a new understanding of what a number fundamentally is beyond just its use in counting or measuring.
How does that show up in his work?
Look at how he treats 1 and 0. It's fascinating. Vetrovkova points out he sees the unit 1 as the absolute foundation of all numbers. But crucially, he places it sort of outside the category of number itself.
Outside? How so?
Because 1 isn't composed of anything else. It's determined by itself, in his view. It's the source, the indivisible starting point. It almost has this metaphysical status, the ground from which all multiplicity, all other numbers emerge.
Okay, that's definitely a philosophical stance, not just a mathematical one. What about 0?
0, or Sifr, is the complete opposite. In his system, it has no independent reality. It's not a number representing a quantity. It's purely a syntactic marker, a placeholder. It signifies absence within the structure of the notation.
Wow. So 1 is the ultimate presence, the source, and 0 is structured absence.
That's a great way to think about it. This asymmetry isn't just arbitrary. It reveals these deep metaphysical assumptions about presence and void, unity and negation that were likely embedded in the intellectual currents of his time. It's philosophy encoded in math.
And these weren't just his own ideas floating in a vacuum. They connected to broader traditions.
Absolutely. Our sources emphasize the context. Islamic theology, Greek philosophy, but also very strongly, Indian metaphysics. Remember his arithmetic book reference Hindu calculation?
Right.
Well, it also explicitly talks about calculating with the greatest and the smallest numbers. This phrasing directly echoes categories from the Upanishads, the Hindu philosophical text.
Which category?
Mahato Mahyan, greater than the greatest, and Autoraiyan, smaller than the smallest. These terms are used to describe the infinite and infinitesimal nature of Brahman, the ultimate reality in Hinduism.
So he's possibly seeing number as a way to engage with these cosmic scales, the infinite and the infinitesimal.
It strongly suggests that, yes, for him, numbers weren't just for counting sheep or calculating taxes. They were tools to contemplate the vastness of reality. Even incredibly huge numbers, like the 4.32 billion years representing a day of Brahma in Hindu cosmology.
Which would have been almost impossible to even write down easily before his system.
Exactly. The decimal place value system he introduced made such numbers manageable, conceivable. The mathematical mind itself became a vehicle for exploring the scale of the divine, the scope of cosmic time. Computation becomes contemplation.
That really reframes the purpose of adopting the decimal system. It wasn't just about efficiency.
Efficiency, yes, but also symbolic power and logical elegance. Think about it. Reducing the infinite possibilities of number down to just 10 symbols and their positions. It reflects this deep philosophical idea that profound order can arise from simple, minimal means, that a well-structured language, like this number language, can unlock universal patterns.
It's an economy of thought.
A profound economy. Vetrovkova highlights that while many civilizations had number systems, Al-Khwarizmi's use of place value was a leap in logical expressiveness. The number 325 isn't just 3 symbols. It's a structured expression where position gives meaning hundreds, tens, ones. Syntax and semantics merge.
And this structured thinking extended to his algebra, too.
Yes. His method stating a general rule first, then giving specific examples, has that deductive feel like Euclid's geometry. But unlike Euclid, who was mostly focused on static proof of what is, Al-Khwarizmi was focused on operational procedures. How to do things, how to systematically solve problems.
A dynamic approach again, finding a method, a process.
Exactly. He saw generalizable procedures, a way to think through problems systematically. And his method emphasized clarity, making the steps universal, reproducible, all hallmarks of what we now call algorithmic thinking.
Which is why Vetrovkova says he laid the foundation of algorithmic thought, even without using the term itself.
Precisely. The fact that our word algorithm comes from his name isn't just a coincidence. It reflects that his style of thinking, structured, step-by-step, symbolic, really did inaugurate a new way of approaching problems, a new way of organizing thought.
And this links back to the ethical and pedagogical dimensions we discussed earlier.
Absolutely. For Al-Khwarizmi, the elegance and clarity of his mathematical methods weren't just about being clever. They were tools for cultivating mental discipline, for achieving moral clarity. The algorithm wasn't just a calculation tool, it was a mental path.
A straight way, out al-mustaqim.
Exactly that phrase is used. A straight path for reasoning itself. His works implicitly teach that clear thinking is connected to wise living. That structured reasoning, balance, proportion, these are almost spiritual practices, ways to align the human mind with the perceived order of the cosmos.
Which ties into the Quranic idea of the universe being created in due measure and proportion.
It resonates strongly. His algebra, with its balancing muqabala of equations, and his arithmetic, handling vast scales through ordered structure, they feel like philosophical grammars of the infinite. They train the mind to see pattern, balance, harmony qualities believed to reflect the divine creation. Understanding this mathematical order becomes part of understanding your place as a conscious being in a rational universe.
So he's not just the father of algebra, he's almost a philosopher of structure itself, using math to explore deeper truths.
I think that's a fair way to see him. He saw the spiritual in the numerical, the ethical in the formal. His legacy isn't just equations, it's the idea that knowledge, especially structured knowledge like math, can be a bridge between the tangible world and deeper realities.
Okay, we've seen him as educator, scientist, philosopher. How does this all come together? What's the synthesized view of his enduring impact, especially looking back from our algorithm-saturated world? Let's wrap up with his synthesis and legacy.
Right. When you step back and look at all these threads, the pedagogy, the science, the philosophy, what really emerges is, well, a civilizational thinker. Someone whose vision truly fused these different ways of knowing.
Not just a specialist.
Definitely not. His algorithm, that word derived from his name, wasn't originally just about computing steps. It was bigger. It was a whole worldview, really. A template for how to reason, how to learn, how to live in tune with what he saw as a divine order.
And that integration was key to his influence.
Absolutely. The way his educational aims infuse his scientific work is clear. Remember the goal of forming a virtuous personality, constantly seeking knowledge. That wasn't separate from the math. The math was part of that formation. He embedded the procedures within these larger ideals.
And he shared it widely.
Critically, yes. As Brentius showed, his work spread through translation and adaptation across cultures. He wasn't locking knowledge away. He was building channels, creating systems others could use and build upon. He was an architect of knowledge transmission.
So his algorithmic thinking, that clear step-by-step symbolic approach, it became more than just a technique.
It became a cognitive discipline, a way of training the mind that influenced scholars for centuries. Vetrovkova points out how it paved the way for later European algebra, even while, for him, it still carried those ethical and metaphysical echoes.
Which brings us to that irony you mentioned.
Yeah, the irony today is that algorithms are so often seen as purely technical, value-neutral tools. Stripped of that original humanistic and even spiritual context, we talk about bias in algorithms, sure, but often miss that deeper question of intention and worldview that was present at the origin.
For Al-Khwarizmi, the algorithm wasn't just a function, it reflected something deeper.
It was like a mirror of divine order, a process that could align the human mind with the elegance and structure of creation itself. You see this, too, in how he handled concepts like 1 and 0.
The unity and the void.
Exactly. It shows he saw mathematics not as some arbitrary game, but as a kind of spiritual architecture, a way to map both the understandable parts and the mysterious depths of the universe. Counting wasn't just tallying. It was discerning the rhythms of existence. His books weren't just manuals. They were almost like meditations on how a finite mind can grasp at the infinite.
And this vision crossed borders.
Massively. His work became foundational in Europe through Latin translations by Adelard of Bath, Gerard of Cremona, and others. The decimal system, algebra, they became pillars of the medieval and Renaissance curriculum. His influence flowed through Latin, Hebrew, Arabic traditions simultaneously. His algorithmic worldview became this shared transcultural inheritance.
Seeding the idea of universal knowledge.
You could say that. And if you think about later ideals, the Renaissance polymath, the Enlightenment rational individual Al-Khwarizmi seems like a forerunner. He embodies that Islamic ideal of ilm, knowledge, as both a sacred calling and a civic good.
So his legacy really pushes us to think about what knowing means. It's not just information, not just computation.
It's synthesis. It's harmonization. It's elevating the mind towards ethical clarity, towards a sense of wonder about the cosmos. It's integrating what you know into who you are.
Which feels incredibly relevant today with AI and algorithms reshaping our world.
Extremely relevant. Maybe returning to Al-Khwarizmi isn't about ditching modern tech, but about recovering his intentions. His algorithm aimed to humanize thinking, to teach balance, proportion, clear reasoning, even humility. His legacy challenges us not just to code better, but perhaps to think and live more wisely.
So we've journeyed through the incredible world of Al-Khwarizmi, a figure who really did weave together the symbolic and the spiritual, the rational and the ethical, into this cohesive vision of knowledge.
He showed us that seeking knowledge could be a deeply moral act, an act of devotion to finding order, clarity, and balance in the universe, seen as reflecting divine reason.
His algorithm wasn't just a mechanism. It was a pathway structured, yes, but aimed at inquiry and self-refinement, a method for living wisely.
A tool for perfecting the intellect and the soul together.
Which leaves us with a final thought, especially pertinent today. In a world where machines increasingly think for us, Al-Khwarizmi's legacy prompts a vital question for you, our listeners, to ponder. Can knowledge truly make us more human, more connected, more ethical?
Or, in our drive for efficiency, are we maybe losing sight of that deeper, humanizing purpose of understanding? What does it mean for you, personally, to connect your own intellect, not just with information, but with that sense of wonder and wisdom that Al-Khwarizmi embodied?